Welcome to the YouTube channel of Lauterbach Verfahrenstechnik. Today we will perform a strength calculation using our LV FEM Toolbox. And for that we will have a look at the task. We have a vessel with 4 nozzles on the top, on the bottom and on both sides. The vessel is filled to a certain filling level with a fluid medium, and we will have a look at the leg supports in the next video. Our task is to calculate if these nozzles and vessels are strong enough to withstand the mechanical stresses. So there are forces and moments applied at every single nozzle, and we want to find out if the material, if the nozzles and the vessel itself withstand those stresses. To calculate this, we will start by entering all data in the module. We will open one module per nozzle, so in our case 4 modules in general. We will start the calculation interface. We will perform the automatic and simplified calculation, and our result, our output, will be the calculation of the stresses and loads applied to the nozzles and the container. I also want to mention that it is very easy to print out the results of the calculation or export them as a PDF file or as a Microsoft Word file. This is the general overview over our whole interface. On the left side you can see the list of the modules. On the right side you can see the module itself, where you can enter all your data. And first of all, you have to select a model. For example, a spherical dished head, a flat head, a vessel with leg support. And in this example, I chose the cylindrical shell with a single nozzle. We enter our boundary conditions, so temperature, pressure. We will select the materials of the vessel and the particular nozzle we have a look at. We entered all the geometrical data of the shell and the nozzle. Optional, as an option you can choose a nozzle reinforcement, and in this case, if you chose a reinforcement, you can enter the thickness or the diameter of the reinforcement. You also have the choice to choose where forces and torques are applied, at the end of the nozzle or at the connection between nozzle and shell. In this case, the shell is the cylinder. You have another option. You can consider or not consider the internal pressure of the shell, in our case of the vessel. You can enter the forces and torques according to nozzle spec, or you can enter them by yourselves, so you can put them in freely if you want to. And you can also choose the diameter for nozzle spec if you choose to define the forces and torques by nozzle spec. In the end of the module you get a summary of all the forces and torques applied to the nozzle. And by simply clicking the Start Console button in the top left corner, you can start the calculation interface. So here you can have a look at the calculation interface. You can access it by clicking on the Start Console app button in the FELV module. On the left side you can see all the data that you put in the module: temperature, pressure, E-moduli of the materials of the nozzle and the shell, the forces and the torques, and at last the net parameters. This is where you can always check the data you put in the module. You can also have a look at the net. You can zoom in, you can zoom out, you can also turn the model around, look at it from different views. You can look at the deformation, the tangents, in which areas the tangents are especially strong. You can have an isolated look at the tangents in the decay area. You also have the option to perform a linear bulging analysis. You can turn the model. You could zoom in or zoom out as well. This way you can see where the deformation is especially strong. And you can see the critical load factor. The next model we'd like to show you is the flathead. You can also turn the model around, zoom in, zoom out. You can also have a look at the net, at the shell. On the right side, you have the option to, for example, adjust the maximum of the colored scale that you can see when we click the stresses. You can also have a look at the deformation, at the stresses. Again, isolated looks at the different parts of the model, just the shell, just the nozzle, or optionally just the reinforcement if we had put in a reinforcement in the module. And the third model we'd like to show you is the dished head. You can also turn the model around, zoom in, zoom out. Again, the same options on the right side. You can also have a look at the net here. You can have a look at the shell, the deformation. You can have an isolated look at the deformation in the decay area. You can have a look at the mesos stresses, again, at the different parts, different areas of the whole model. You can show or hide the outer lines of the model. On the left side, you can, for example, I put the lower boundary of the ISO clipping to 80 newtons per square millimeters, which means that only the stresses over 80 newton per square millimeters will be shown. And here again, you have the model. So in the end, you can see the results. They will be transferred from the calculation interface to the FELV module, and you can always have a look at them there and save them. Thank you very much for your attention. If you have any questions, you can always feel free to ask. Leave comments in the comment section or mail us, or you can also call us every time. Thank you very much and see you next time.